Good morning, students. Today we'll discuss short answer questions from mechanical properties of solids. First question, stress types. Here, from this mechanical properties of solids, you can get one 4 marks question in supplementary examination. Total 4 questions present. Stress types, strain types, behavior of loaded wire, and the last one, elastic potential energy. So we'll discuss first question from mechanical properties of solids. Define stress. How many types? First, stress. What is the meaning of stress? For example, you take one elastic body. This is one rubber ball. Apply force. Just you press ball. Meaning when deformation force, nothing but a force which changes the shape of the body. So deformation force applied on the body. You treat this the action. For every action, there is equal and opposite reaction. When deformation force, nothing but a force which changes the shape of the body. F, nothing but a restoring force. So, when deformation force is applied, shape changes. Again, we are removing deformation force. Automatically, restoring force. Effect of restoring force. Again, body gains its original shape. Depend on this concept, we are writing what is the meaning of stress. The ratio between restoring force with respect to unit area. Force, Newton, area, meter per square. So, SI unit for stress, Newton per meter square. Definition very simple. Ratio between restoring force with respect to area. Stress, total 3 types. One is the longitudinal stress. One is the longitudinal stress, also called tensile stress. Next, volume stress. Nothing but bulk stress. Third one is there, tangential stress. Tangential stress, sharing stress. Total 3 types of stress available. What is the question means? Define stress. Explain types. Stress, the ratio between restoring force with respect to area. Restoring force acting with unit cross-sectional area. Newton per meter square. Longitudinal stress. What is the meaning of longitudinal stress? Means when deformation force is applied, its length changes. Stress changes length. When stress changes length, automatically longitudinal stress nothing but restoring force per area. This is related to length. What about volume stress? When stress applied, its volume changes. Then restoring force per area. Every statement definition same, but what is different? Here, restoring force per area. When deformation force is applied, its length changes. Deformation force changes its length. Then restoring force per area. Deformation force changes volume of the body. Ratio between restoring force per area. Tangential stress. restoring force applied on the body, its shape changes. Here, length changes. Here, volume changes. Here, shape changes. Except these three words, remaining statement same. Again, I am repeating. Explain stress types with what is the definition of stress. Define stress. Explain various types. What is the stress? Deformation force is applied. You are writing the deformation, that one all secondary. Just ratio between restoring force with area. Everywhere restoring force per area. Restoring force per area, restoring force per area. Here, deformation force is applied, length changes. Deformation force is applied, volume changes. Deformation force is applied, shape changes. This is stress. Almost all definitions same. Here length changes, here volume changes, here shape changes. Remaining statement same. This is stress types. Next one is there strain. Strain types. First one is the stress with types. Next one is the strain with types. What is the meaning of strain means? See, strain equals to change in dimension. Change in dimension by original dimension. The ratio between change in dimension, because length changes, volume changes, area changes, like that. Different types of parameter changes when we are applying here deformation force. Stress types, strain types. What is the strain? General definition: the ratio between change in dimension with respect to original dimension. Change in dimension by original dimension. This is the ratio, no unit, because dimension upper, dimension lower, both are same. That's why here no unit. No units for strain. In this one, first longitudinal strain. Longitudinal strain. The ratio between change in the length with respect to original length. Longitudinal word coming means length. Next, bulk strain. The ratio between change in volume with respect to original volume. After applying force, volume decreases. That's why we are writing student minus. Change in the length by original length. Change in the volume by original volume. This one strain cases. That is the stress cases. Stress, equivalent word strain. Longitudinal stress, longitudinal strain. Volume stress, volume strain. Also called bulk. Tangential stress, tangential strain. This is the tangential strain. This statement slightly different. Students, again I am repeating. Today questions from mechanical properties of fluids. First question, stress and types. The ratio between restoring force with respect to area. Restoring force with respect to area, that is nothing but stress. How many types total? 3 types. One is the longitudinal stress, nothing but restoring force per area. When deformation force changes its length, deformation force changes its volume. Ratio between restoring force per area. Deformation force changes its shape. Restoring force per area. Satish. 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 Okay, see. So, 3 different type stress. Here, strain. What is the strain means? The ratio between change in dimension with respect to original dimension. For this one, no unit. Longitudinal strain, ratio between change in the length with respect to original length. Bulk strain, ratio between change in the volume with respect to original volume. What is the tangential strain means? See, just a diagram, I'm drawing one diagram. You take, this is the original length L layers. When we applied force, like this, there is slight variation coming. Like this coming. Now, here. This is the original dimension, length. This is the changed place. We wrote X. Tan theta equals to right angle triangle. Tan theta equals to opposite side by adjacent side. That one only we wrote. Relative displacement in between layers. What is the relative displacement in between layers means? What is the final point? What is the initial point? The difference. Ratio between relative displacement in between the layers with respect to its original length. This is tangential strain. So, one question, stress, it's a type. Strain, it's a type. Next question, behavior of loaded wire. This is the 3-star question, student. Most important question. Up to now, 2 questions over. One is the stress with types. Stress definition with 3 types. Strain definition with 3 types. Next, behavior of loaded wire. Behavior of loaded wire means we want to draw a graph in between stress and strain. For example, one body suspended with string. This is the load. When we are applying load, automatically elongation, length of the wire slightly changes. Wire becomes thin, thin, thin. At a particular time, it breaks. That is called behavior of loaded wire, meaning a graph drawn in between stress and strain. That one only. Behavior of loaded wire. Most important question from this mechanical properties of solids. Total 6 sidedings with one graph. 600% you write 6 sidedings. For each and every 2 sideding, 1 mark. Behavior of loaded wire. What is the behavior of loaded wire graph? This is stress. This is strain. Axis by axis. Here. Now points O, A, B, C, O dash, D, E. A graph drawn in between stress and strain. Total 6 sideding. For graph, you can get 1 mark. Total 6 sideding, student. Here. Number 1, A. Proportional limit. This one, A. What is the meaning of proportional limit means? See, on increasing stress, strain, elongation also more, meaning A proportional limit means just one word. Stress directly proportional to strain. On increasing stress, strain increases. You are writing single word. Stress directly proportional to strain. Hooke's law obeys. Over 1 point. Just highlight sideding. You can get mark for sidedings. B. Elastic limit. Elastic limit means elastic nature present up to B just a slight variation. See, the slight variation meaning elastic nature present, but Hooke's law does not obey. That one only you are writing elastic nature present, but Hooke's law does not obey. Strictly Hooke's law does not obey. Just one word only. What is the first point? Proportional limit. Stress proportional to strain. That's why we are calling proportional. Elastic nature present. That word only enough. Elastic nature present in the wire. What is the third point means? See, yield point. Up to here elastic nature. Now plastic. One is the elastic bodies. Second one is the inelastic bodies. One is the elastic body. Second one is the inelastic. That inelastic we are calling plastic body, student. What is the yield point means? Plastic nature. Plastic nature present. Meaning up to C. Otherwise beyond B when we are removing stress. Beyond B point when we are removing stress. Wire plastic nature present, it won't gain its original shape. That's why you are writing single word. First proportional limit, stress proportional to strain over. Next elastic limit, elastic nature present up to B. Third one, plastic nature present from C point onwards. Yielding starts. Yielding means wire becomes thin, slowly thin. That is only yielding, student. Net. No, here you are writing like this. This is the yield point. Next O dash. Next O dash. Permanent set. Meaning wire stretched permanently beyond C. Wire stretched permanently. Wire stretched permanently. That is called permanent set. Up to now, student, 4 points over. Again, I am repeating. Just you write what is the meaning of that words. Proportional limit. Stress proportional to strain over. B. Elastic limit. Stress not proportional to strain, meaning Hooke's law does not obey, but elastic nature present. Yield point. Plastic nature present. Plastic nature starts from C point onwards. What is the permanent set? We are removing load. On removing load, wire stretched permanently. That is only permanent set. Next to D point. D point nothing but tensile point. Tensile point D. What is the meaning of D here? In the absence of stress, elongation more, meaning that wire ready to break. First situation, meaning in the absence of stress, elongation more. Practically, we are not applying load, wire becomes thin. That state we are calling D. Tensile point. In the absence of stress, elongation more. Last one, student, E. Breaking point or fracture point. Wire ultimately breaks. Where wire breaks, that point we are calling E. E nothing but a breaking point. So total 6-sided heading. One more time I'm repeating. First, explain behavior of loaded wire. Focus on graph. A graph drawn in between stress and strain. Total 6. Just focus on side heading. In intermediate first year, you are getting from 2 questions, side heading questions, student. Only for side heading only you can get mark. One is behavior of loaded wire. One more, I already finished. Decreasing, method of decreased friction. Method of decreased friction means 4 marks for 4 side heading. One is the polishing, one is the lubricants, one is the ball bearing, last one is the streamlining. 4 side heading, 4 marks. Here 6 side heading, 3 marks with 1 mark graph. Total 4. Proportional limit, stress proportional to strain. Elastic nature present, elastic limit. Yielding point, plastic nature starts from C point onwards. Wire stretched permanently, permanent set. In the absence of stress, elongation more, tensile point. Last one, wire breaks, that is the breaking point, student. Before that one, stress and strain, individual question. Stress definition, 3 points. Strain definition, 3 points. In this one, last question present, that is nothing but what is that? Potential energy or elastic potential energy comes. Sometimes they're asking strain energy of wire. Define strain energy. What is the expression? The question, 2 different forms, answer same. Strain energy, elastic potential energy. Strain energy also called elastic potential energy. What is the meaning of strain energy definition? See, for example, you take one rubber material. When we are pulling rubber, that rubber or elastic body, it stretches. That is called strain energy. Energy stored in a body due to its deformation. For example, you treat this one rubber material, I am pulling. What the energy I required means strain energy. Energy stored in a body due to its deformation. We want proof 1/2 into force into elongation. This is the formula for strain energy. Simple derivation for there. Now proof. For example, you take one elastic body, you apply force. What is the work done? Work formula, you know, force into displacement, student. Depend on this one, I am writing work equals to force into displacement. We are doing integration. What is the purpose of integration means? By using integration, we can get overall energy. Work equals to force into displacement. When we are applying force in a body, this body deformation force we are applying, automatically deformation means what is that? Shape of the body changes. When we are applying force, what is the amount of work done? This is the work done formula, force into displacement. Young's modulus is Y. Already this question came in previous annual examination. Define Young's modulus, bulk modulus, rigidity modulus. Young's modulus Y. F is the external force. L is the elongation. Capital L is original length of wire. You know Young's modulus formula. Young's modulus equals to longitudinal stress by longitudinal strain. force per area by change in the length with original length. From this one, I am writing like this. Y equals to F by A. This fraction changes. Then, what is the force formula? Y A L. Y A L by capital L. Equation 2, equation 1. Substitute equation 2 in 1. So, work equals to force into elongation. What is the force concept mean, student? Previous formula only. Ya small l by capital L. So, YAL by capital L into DL. Integral dW means W. Constant, constant, constant. Young's modulus constant only. Area constant only. L constant only. LDL. Yesterday I said we are not doing differentiation. We are not doing integration. Constant. This is the integration, student. Power 1. What is the mathematical formula? X to the power of n dx means x to the power of n plus 1 by n plus 1. Based on this mathematical formula, we are writing here work equals to YAL by x to the power of n, L to the power of 1, x, nothing but L. 1, n means 1 there, 1 plus 1 by 1 plus 1. Work equals to Ya into L square divided by 12. This work convert into potential energy. So U nothing but potential energy. I'm writing this one 1 by 2 into YAL by capital L into L. L square we wrote L into L. YAL by capital L. YAL by capital L nothing but force. Previous equation number 2. Ya small l by capital L nothing but force. This one only our answer. U equals to 1 by 2 into this one force, this one elongation. This is elastic potential energy. Now I am giving one more time 4 questions explanation here. Today concepts very easy concept. Here student first question, stress. What is the definition of stress with types? Stress, the ratio between restoring force with respect to area. You are writing ratio between restoring force per area. Units Newton per meter square. How many types? 3 types. One is the longitudinal stress, meaning deformation force is applied. Length changes. You are writing on applying deformation force. Length changes. Then restoring force per area. On applying deformation force, volume changes. Again, restoring force per area. On applying force, shape changes. Restoring force per area. This is the stress with different types. Again, one more question, strain. Ratio between change in dimension with respect to original dimension. No unit for this one because numerator, denominator always same physical quantity coming. That's why units cancel each other. No unit. Longitudinal strain. Ratio between change in the length, original length. Bulk strain. Change in the volume, original volume. This minus indicates volume decreases. Tangential strain relate to displacement in between the layers with respect to original length. So, one is the stress, second one is the strain. Next, behavior of loaded wire. Total 6-sided ring, one line enough student. Graph, a graph drawn in between stress and strain. Proportional limit up to A, stress proportional to strain. B, elastic nature present. C, Yield point, plastic nature present from C point onwards. On removing load, wire stretched permanently. That's a permanent set. 4 side headings over D. Tensile point for small stress. In the absence of stress, anything no problem. For in the absence of stress, elongation more. D. E point, wire breaks, wire fracture point, breaking point, both are same. A point where it breaks. This one is the question number 3. Now, last question, strain energy. Energy stored in a body due to its deformation. So, we are applying force on a body, automatically its shape changes, student. We are writing energy stored in a body due to its deformation. Work equals to force into displacement. Young's modulus formula Y equals to F by A into capital L by small l. In this equation, capital L is the original length, small l is the elongation. Substitute here, mathematical calculation we are doing Y A small l by capital L into DL. Substitute 2 in 1. Right outside. What is that integration? L dl means L square by 2. That is only our answer. U equals to 1 by 2 into, you separate L square, L into L. This is the force concept, that is the elongation concept. So, we are getting finally U equals to force into elongation. This lesson from mechanical properties of fluids, from this lesson you can get 4 marks. Tomorrow, last topic, student, heat concept. Day after tomorrow onwards, Monday onwards, we are going towards VSAQs. Up to now, LAQs over. Tomorrow, I'm finishing SAQs. Day after tomorrow onwards, VSAQs. Okay, we'll continue next class.